Well, hi again. In this video, I will try to show you binomial distribution, how to apply them, how to use your calculator. So binomial distribution is a special case of discrete distribution. And when it's happened, we need to verify these 4 steps of the binomial distribution. Fixed number of trials. Trials are independent. For each trial, there will be 2 mutually exclusive, not intersection. Success or failure. Probability of success must be fixed. So you gotta know this part. And then you need to identify your n, number of trials, your probability of success, p. 1 minus p is q. It is coming from the complementary event. So probability of event is happening is p. Probability of event is not happening will be 1 minus p. And x will be the binomial random variables that denotes the number of successes between 0 and n trial. So we cannot look for an x greater than number of trials. All right, so there were examples, we went over that, hence this is 6.2 PowerPoint slides, and we have come till slide number 26. So all the questions that you're seeing in your group work can be done by using this PowerPoints. We did not use the combinatorics formula, but we barely touch with that. So we need to know this math symbols, at least or no less than, more than, greater than, fewer than, less than, no more than, exactly or equal to. So how to interpret them, how to mathematize them. We gotta know that. So let's go ahead and start to do with this example first of all. For example, in a random sample of 20 cards, so n is 20, what is the probability that less than 4 have 3 or more cards? So we're going to be looking at a binomial probability here because there is a fixed number of trials, 4. Each trial is independent. The probabilities are the same, 35%. So one way of doing it in this slide, because we were looking for probability x less than 4, it means that exactly the same thing, x less than or equal to 3. Remember, binomial is discrete. If it is x less than 4, it cannot be 4. That well, I'm looking for the numbers less than 4. It will be 3, 2, 1, and 0. There's a way that we can find it by calculating each of these probabilities and add them up. So how do we calculate those exact probabilities? By using our calculator. So if you're looking for a probability of x equals to something, you can use from your calculator binom PDF. For instance, this example. We were looking for the wireless houses only, and this is the percentage, 41%. We have 20 houses, and is equal to 20. So what is the probability that when we pick up, 5 of them will be wireless house? So we're going to pull out our calculator. Let's see, all right, here. I want to use the double screen so then you can see which number is going where. It's not going to happen that way. Okay. So on our calculator, we're going to second distribution. And from this long list, we need to find the binomial PDF. You can go by arrow, and it will be A, letter A, or you can just jump into letter A. Okay, so let me do that. Second distribution by pushing that alpha and math. It will take you to binomial PDF. So trials is 20. Okay. And sometimes my screen emulator, it's not working. Let's see. 20. Yeah. All right. Well, 23 is okay, but we don't want 23. I can enter. All right, 20. Nice. So enter. Probabilities 0.01. Okay. Enter. What do we want? We want the x value will be 5. Okay. Paste. Enter. Enter. So that's the probability. So what does that show? In this context, knowing that 41% of all US households are wireless only, the probability of choosing 5 households with wireless only is 0.0656. Have 4 places after decimal. What is the trick in this question? Because we're finding a probability x equals to, we need to use binomial PDF. All right. So I will be going to next one. What is the probability that fewer than 3 houses are wireless only? So when you start to use less than or equal to, greater than equal to, the comment on the TI-84 will change the binomial CDF, but there are different versions of binomial CDF. So probability of less than 3, it means that probability of less than or equal to 2 means that probability of 2, probability of 1, probability of 0. Okay. So we're going to go second quit, second distribution. Okay, now we're going to go to binomial CDF. This is B, I believe. Yeah, it's there. Right, this one. You can just jump in there by doing second distribution, then push alpha, and then push B. Yeah. So how many trials we have? 20. Oh, my calculator is so adamant with the 0. Okay, let's try 23. All right, clear. 220. Yes. Enter. And the probability is 0.41. It did not change. And enter. X value should be 2, whatever the x value we're seeing here, x less than or equal to 2, because this comment is give us the probabilities of x less than or equal to a number. Right, that's the trick maybe. And then enter, enter, enter. So I think I rounded up here 27/8. So that will be the probability. All right. So moral of the story, when you're calculating a binomial probability, if you need to use less than or equal to, less than, or greater than, you need to use binomial CDF. It's under second distribution, I have shown you, with different versions of it. You got to write down what's the probability that you're finding, that black portion, and what is the command actually that you're entering, you're thinking to enter in your calculator, and then your result. Again, hope this helps. Please make sure that you watch these videos and come prepared to class tomorrow. All right, see you soon. Bye.